Today we're doing section 4.6, day 3, and we're going to discuss how to graph the tangent function. So the other four, the process is very similar. Tangent and cotangent are very different than the other four. But I think these are a little bit easier because the process is less steps, so less information to obtain. So tangent has a bunch of asymptotes. The way we find the asymptote is you will have negative pi over 2 less than, and the bx minus the c is the same from like before. Whatever is after the tangent function gets filled in here. And then it's less than a positive pi over 2. And you're going to solve for x. Once we solve for x, that's going to determine the placement of our asymptotes. The amplitude is the idea of the slope in this case. So if it's positive, our tangent graph will look like that. If our a value is negative, our tangent graph will be upside down and overall have a negative slope. To find our x-intercepts for these, our x-intercepts are halfway between asymptotes. And the period is the distance between the asymptotes. So distance between asymptotes. So there is no set formula to find the period. There is no set formula to find the x-intercepts. We just kind of find the asymptotes and then we fill in the information from there. So for the first example, or only example today, your group paper might say something different. I'm not sure if I changed it on your hard copy or not, but the equation should say y equals 2 tangent of x over 2. So notice this is, that part in the parentheses is our bx minus c. So we're going to take that, and that's what we're going to set in the center of the two inequalities. The way we solve for x will be different for every single problem, so I can't say that every single problem will be set up the same. So in this instance, to get x by itself, I multiply by 2. That will not be the same for every problem. So to get x by itself, I multiply by 2, but I have to do it on the left side and the right side because there's two inequalities. When I multiply by 2, the 2's cancel, and I have negative pi is less than x less than a positive pi. So the period would be the distance between these two asymptotes. So I have a negative pi to a positive pi, so the total distance would be 2 pi. And my asymptotes, or sorry, not my asymptotes, my x-intercepts are going to be halfway between the asymptotes. So halfway between negative pi and positive pi would be 0. You might want to wait to do that until you can visually look at these. Sometimes if you're more of a visual person, it helps to look at the graph to figure out your x-intercepts. So to get this on our graph, we are going to be putting an asymptote at positive pi and negative pi. Mine got a little cut off, but it's definitely on your paper, so it's right there. And we're always going to do 2 periods worth for these. So I have an asymptote at negative pi, at positive pi, and then the next time it'll happen is at 3 pi. And again, mine's a little cut off. It's on your paper, though. So we'll always graph 2 periods. Halfway, again, is 0. For the other x-intercept, halfway between pi and 3 pi is 2 pi. My a value is 2, so we can use this. So if you look halfway between the x-intercept and the asymptote, is at pi over 2, and that's where we would put the a value of positive 2. And then over here, I would go to negative 2. And my picture looks something like that. And then again, that pattern is repeated. And it goes like that. Domain and range are a little bit tricky. Again, we have exceptions. So the domain is negative infinity to infinity, except, struggling with my pen today, except multiples of odd pi. So the asymptotes were at -1, +1, +3 pi. Next time it would be at 5 pi and so on. Our range will be -infinity to infinity. So that's all for today. We'll practice tangent tomorrow.